Hello all, welcome again. This is Bitwise Operators session or FAQ session on Bitwise Operator, and we already discussed about bit masking. I hope you thinking that you understand bit masking. If you did not go through our FAQ session, please kindly go through our embedded C frequently asked questions. We discussed in deeper about bit masking. So please subscribe to our channel if you did not subscribe to our channel by clicking subscribe button for more updates, FAQs, concepts on embedded, etc. So let's straight away get on to the first question. Compute the sign of an integer. So the MSB bit of a number defines their sign, that is most significant bit defines their sign. So if the MSB bit is set, the number will be negative, right? So we'll see with a small program hash include stdio.h int main. I define a variable called sign, int sign equal to 0, int data equal to 0. Printf, enter the number, scanf percentage d and ampersand data, that is get the number, sign equal to data greater than 0 minus data less than 0. Check the sign of the number. If sign double equals to 1, then printf enter the number is positive number in a new line. Else if sign equals to double equals to minus 1, printf enter number is negative number. Else printf enter number is 0. Only these three are possible, right? If not, it returns 0. Let main returns 0. If I repeat, if printf, if sign double equals to 1, enter number is a positive number, and else if sign double equals to minus 1, entered number is negative number, else printf enter number is 0. Only these three things are possible. This is how we compute the sign of an integer. Let's get on to the second question. Detect if two integers have opposite signs. The two integers have the different signs if their MSB, that is bit, is different. In C language, use XOR operator. We can check the sign of the integer. We know that for the same input, XOR produces the low output, and for the different input it produces the higher output. So that can be checked with the truth table of XOR. If bit 1 and bit 2 and bit 1 XOR with bit 2, if 1 is there, it will be 0. If it is 0 0, and it will produce 0, and if it is 1 0, it will produce 1, and if it is 0 1, it will produce 1. Exactly like this in the table. So if both signs are, so I repeat, the same input produces low output, that is 0, and for different input it produces high. So then we can write the program. Let the given integers are a and b. The XOR sign of sign bit MSB of a and b will be 1. If MSB of a and b is different, in other words, we can say XOR of a and b will be negative if a and b have the opposite signs. Okay, so for that we can simply write using an stdbool.h and stdio.h bool check opposite sign, a small function or a method, bool check opposite sign. So we pass int a and int b. So bool b return value equals to 0. I'm something like this. Bool b return value equals to 0, b return RET value equal to A XOR of B less than 0. That is I if A and B have opposite sign. Return B return value. This is how we check for opposite signs. Okay. So if A and B have opposite signs, then it would be 1, right? It produces high as far as we checked in the previous table. So this is how we detect if two integers have opposite signs, right? And coming to the using this method, we can call it in the main is something like this: integer main int a equal to 0, b equal to 0, bool read value, enter the value of a and b, printf enter the value of a, and scanf for that particular value, and printf enter the value of b, and scanf for getting the value of b. So this is how b return value is equal to, we call that method check opposite sign a comma b. If true equal to b return value, printf integers have opposite sign. So if true equals to b return value, okay, printf, else printf int integer value have the same sign, return 0. So this is how we call in the main function of the method we discussed previously. This all depends upon that XOR truth table. This is how we detect the opposite signs. Let's move on to the next question. Write a program to check an integer is a power of 2. That is, if you have 2, 4, 8 will have a power of 2, right? Here I am writing a small algorithm to check the power of 2. If a number is a power of 2, the flag will be 1. So something like I use this integer main, integer flag equals to 0, integer data equals to 0, printf the number, scanf for to get the number, and flag equals to data not equal to 0, double ampersand, that is and not data and data minus 1. That means we are trying to check the power of 2. If flag equals to 1, what happens? It has to print something like number is the power of 2. Else printf enter the number, it is not the power of 2. So note here I assume that the bit of register starts with 0th position. It means the second position is actually third bits, right? Something like this, D0 to D7. Okay, hope you understood this. Now let's move on to the next question. How to set a particular bit in C? So this is what we discussed in our bit masking also earlier. So once again I'm repeating this. Setting a bits bitwise OR operator, that is OR symbol, used to set a bit of integral data type. OR of 2 bits is always 1 if any one of them is 1. This is given in the truth table of the OR, right? So OR of 2 bits is always 1 if any one of them is 1. An algorithm to be set the bit is number or equals to 1 left shift nth position. Okay, length position, that is 0x01. We are setting the position. A simple program to set a bit is something like in integer main, where it takes argc argv value, unsigned char c data is equal to 0x00, I position equal to 0, and printf data is this thing by percentage d, and printf enter the position which you want to set, and just call the scanf function to get the position of it, just like this. And then C data or equal to 1 left shift I position, print the data. Printf /n/n percentage d dth bit set. Now C data will be 0x percentage x slash n. And what are the percentage d? The first stuff is I position and second stuff is C data. This is how we print it and return 0. So you should try this with your respective compiler while I'm telling you, or you repeat the video and do it, then you would understand better. Okay, so let's move on to the next question: how to clear a particular bit in C. So we just saw how to set a bit, right, by using OR operator, but bitwise AND operator used to clear a bit integral data type. AND of the two bits is always 0, right? If any one of them is 0, an algorithm to clear the bits is 0. An algorithm to clear the bits is number and equals to complement of 1 left shift nth position. Will make that particular position to be clearing by complementing it, right? To clear the nth bit, first you need to invert the string of the bits and then AND it with the number. A simple program to clear a bit can be written like this, with unsigned character data 0xff int I position equals to 0, printf C data and enter the position by scanning for I position. Clear the nth bit. C data and equals to complement of I left shift position will do the clearing of the bit. So we can print that bit as /n/n percentage d bit clear. Now C data will be 0x percentage x slash n. This 0x percentage x is corresponds to C data, and initial percentage dth bit corresponds to I position. That means the fifth, suppose I have a fifth position to be clear now, fifth position, and the data is this thing. After clearing the bit, this is what it gonna produce. Okay, return 0. This is how we clear the data. So let's move on to the next question: how to check if a particular bit is set in C. To check the nth bit whether it has been set or this thing, shift the one in nth position towards the left and then AND it with the number. An algorithm to check the bit equals to number AND with 1 left shift nth position. Let's see, just like this: bit equal to number AND with 1 left shift with nth position. So let's check with the small program. So similarly we will have a C data of 0x fc. I choose the fc because all 1 and 1 0. Okay, int I position is equal to 0. I print of the data. I wanted to enter the which position. I scan for the which position it is, and then if C data and with I left shift I position, check bit set or not. Printf bit is 1, else printf bit is 0. This is how we check for the whether the bit has been set or not. So try it with your compiler. Little minor changes depending upon the compiler. You might already have some macros already available. Such things would be there, but do this for your understanding. So we'll move on to the next question: how to toggle a particular bit in C. So toggling, this is often we use in embedded systems, and a port is considered to be a byte, right? A particular bit, that means particular port can if it toggles, we can toggle an LED, something like that. So we can do this with bitwise XOR operator. Use bitwise XOR operator to toggle the bit of an integral data type. To toggle the nth bit, left shift nth position towards left and XOR it. So the algorithm will be something like this: number XOR equal to 1 left shift nth position 1 to the nth position. And we'll see a simple program how we do it. I have a data 0xfd in C is C data equal to 0xf8. So I scan for the position C data equal to cap equals to I left shift I position. Just now we discussed this algorithm, right? This is, then we can print it percentage dth bit set. Now C data will be 0x percentage x, that is fifth. Suppose my position is 7th position, 7th bit set now, and the C data value is this, and return 0. Try it out with various positions and try it out. If it works, you still can optimize this code. Those things we'll discuss later, but this is for your understanding, keeping in mind with the average aspirants who wants effective understanding of how it works. So you can go with step by step debugging and see the output in your debug window. That's how you can get more understanding. Let's get on to the next question. Write an efficient C program to reverse bits of a number. This is the most frequently asked question. There are a lot of ways to reverse the bits of the number. Here I am describing the 3 general methods. Let's go with the method 1 first and then the rest 2 methods. So in this method we will check the set bit num and run the loop through all bits of an integer. If we find the ith bit of number is set, then just put or at the int underscore bits -1 minus it position of temporary, where int underscore bits is number of bits on an integer. I repeat, in this method we'll check the set bits of num and run the loop through all the bits of an integer. If we find the it bits of num is set, then just put or at the, just like this, in bracket int underscore bits -1 minus it position of temp, where int underscore bits is the number of bits in an integer. Let's see the code with I will use a small macro called size of a character bits, which hash defined character bits, size of character int bits, that is size of int pointer character bits. This is a program regarding to reverse the bits. So I initialize a variable called iLoop, which is of unsigned int, and temp, which is of unsigned int, and then int I number loop equal to int underscore bits. So for colon I loop less than I number loop and plus I loop if num and with 1 left shift I loops. So check the set bits of the number. Okay, we are checking the set bits of the number. Then temp r equal to 1 left shift of the algorithm we discussed earlier, int underscore bits -1 minus I loop, putting the set bits on of number in temporary. So we are returning this temporary to reverse the bits function, right? To call them in any main, we can call this method. So let's look at the second method. It is a simple algorithm to reverse bits of 32-bit integer. This algorithm uses the eighth constant value of a reversing the bits and takes 5 simple steps in the below section. I am describing the functioning of each step. Step 1. Okay. Step 1. Num equal to num and with 0x that is 32 bits. Okay, great. Right shift 1 and or with num and with 0x 55555555. So these two are complement bytes, you can say. Left shift for 1. So this is the first expression used to swap the bits. Let an example suppose num equal to 0 1 0 0. After the above expression, it will be 1 0 0, right? Step 2 is num equal to num and with 0x c. Okay, left shift twice and num and with 0x 33 left shift twice, that is 2. Above expression uses the swap the 2 bits of nibble. Suppose my number is 1000. After the above expression it will become 0001. Okay, next is step 3. So here an expression used to swap the nibbles. Earlier what we did is swap the bits, 1 bits, and second is 2 bits of a nibble. Next we would do a swapping the nibble by using this expression num and with f0 that is 11111 0000 111. If you see in the binary format, okay, you will understand better. Right shift for 4 times, that means we are swapping the nibble directly, complete nibble. Nibble means 4 bits together is called nibble. So and 0f, that means 0000 So after this expression, suppose my number is 00110 then after the above expression it will become 00100011. This is the purpose of doing this, swapping the nibbles. And step 4 is swap the bytes itself by the following expression num and with ff00 and right shift it by 8 times. We want a byte, right? A byte means 8 bits. So and the other one is 00ff left shift with 8 times or both the expression. This will result in swapping the bytes of an integer. Let the number is 0000 1 000 0000 1100. After the above, the whole thing will be swapped, right? Whole thing will be swapped. So then the expression will go like this 000. I mean then the value of the byte will be swapped something like so. Right byte comes to the left and left byte comes to the right. Can you see this? So earlier the right byte is in the left and left byte is in the right. After this will happen. Then we can go ahead with step 5 called swapping the half word of an integer. Something like num right shift by 16 times. Here you don't require any masking or this thing, just right shift and left shift and make an OR expression. Means that if the number is something like this huge, what we'll do is we'll completely take the half word. Half word means 16 bits. 16 bits from the left will move to right, 16 bits from the right will move to left. Okay, all the half word and a half word will be swapped just like this. Okay, this is step 6, and we will use a small bit reversal function where we will the same thing can be implemented just like this in a method. Unsigned int, reverse the bits. Okay, and okay, something like this. But just now we discussed all the steps, right? First uh, 1 bit swapping, and next is 2 bit swapping, and then is a nibble swapping and a half word, and then return the whole stuff. Half word this thing. So this is how we reverse the bits of the given 32-bit byte or whatever data, 32-bit data you can say, right? So here I am ending up with the method 2. Let's move on to the next question. So most frequently asked question, write a program to count set bits in an integer. So there are a lot of ways of writing to count the number of bits in a given number. Here I am using 2 approaches. One is naive and brain kernel hands, and in naive approach requires, this is what expected by most of the people, specifically 1 iteration per bit until no more bits are sent. Okay, you just see hash include std and size of character and size of int of character bits were taken as macros, and we will use this macro in our main. Initially I will declare or set total number of bits set. Okay, variables that set the bits you want to count, and we'll scan for that count, and then while of n count set bits plus equals to n and 1, n greater right shift equals to 1, and printf number of 1 equal to %d. So here what happens is it keeps on right shifting and keeps on giving the count ending it 1. So number of ones can be printed with count set bits, right? So next method is brain kernel hands method, goes through as many iterations as there are set bits. Initialize count set bits equal to 0. If in integer n is not 0, perform bitwise operation and assign the value back to the n. These bitwise operators clear the least significant n and n minus 1 and equals to n minus 1. Okay, increment count set bits by 1. Again go to step 2 once again and come back. If there are no set bits remaining, then return count set bits. Okay, we'll see that. So just start writing the code. This is how it looks. While of n and with n minus 1, clear the least significant bit set, count set bits plus plus, and just we can write away printf number of ones equal to %d, which is the count set bits, right? This is how we can go with that. So another question is rotate bits of a number in C language. So like the assembly in C language, there are no operators to rotate the bits, something like right, left, RL or RR. If you take an example of 8051 assembly, this thing, no, basically bit rotation is similar to the shift operation, except that in shift operation the bits that fall off at one end are put back to the other end. Here are 2 types of rotation possible, left and right. In left rotation, the bits that fall off at the left end are put back at the right end, and in the right rotation the bits that fall off at the right end are put back at the left end. Example, if data is stored using 8 bits, then the left rotation of a data 32, that is 0 0 1 0 0 0 0 0 0 by 2 becomes 128, isn't it? 1 0 0 0 0 0 0. As similar to the left rotation, if data is stored using 8 bits, then the right rotation of the data 32 0 0 1 0 0 0 0 0 0 by 2 becomes 8, that is 0 0 0 1 0 0, isn't it? So this is most likely method. Just let's see with the macros, right? We can simply finish off with using a small macro functions, just like this: hash define right rotation or left rotation, position comma data for left, data left shift position, and or with data right shift int underscore bits minus position. Okay, minus position, and hash define rotate right. So here it's like right shift by position, or with data left shift int bits minus position. So this will do the rest. So how to call them is simply give the position, number of rotations you require, and data which will be rotated. Here I have given 32, but you can do with the scanf, data for scanf for position, and printf data position, and data and position, or rotate. We can straight away call that macro rotate left, so by passing that position and data, and rotate right by passing data and position here. This is how we can do in a simpler manner, but that macros are very important. Please remember the macros which we used. So let's move on to the next question. Compute the minimum or maximum of two integers without branching. Compute the minimum or maximum of two integers without branching. We can find the minimum or maximum number without branching with the help of bitwise operator. Let's assume I have a and b integer numbers, and result is another integer variable that contains the result of the computation. So to compute the minimum number, we have to write the coming expression, something like result equal to b cap, so a cap b, and with complement of a and a less than b. Okay, in this above expression, if a less than b, then complement of a less than b becomes -1. So it behaves like below expression, something like result is equal to b cap a cap b complement of 0, right? Result equal to b cap a cap b. B cap b is 0. When two inputs are the same, it pulls low, right? A cap 0, so with 0 does not with 0 does not affect. ORing with 0, XORing with 0 does not affect, right? So result will be A. Okay. So compute the maximum number will be similar only, but here it will be, here we used for minimum number we used b cap a cap b, and with complement of a less than b, but there it's reverse, a cap b. Okay, for max a comma b. Okay, in this some expression like this, in the above expression, if a greater than b, then it becomes 0, right? So same XORing with 0 does not affect, so result is A, that is maximum number will be produced. I hope you understood this. You will understand this better unless you don't open your IDE and check this, put some inputs, give it, check for maximum minimum numbers, then you will get to know better. You can do it step by step debugging and monitor A, B and the result, then you will understand how the flow is going about. And you can monitor for the expressions. Suppose A cap B, what is the value it is going to generate, A cap of A cap by B. So this is how, if you do it, then you will understand it much better, you will learn it better. So next question is swap two numbers without using a temporary variable. We generally know most of them will use A, B and temporary variable. Without using A, B and temporary we copy B in temporary variable and A will be B will be copied with A, and that's how we used to do in the conventional method. But swap two numbers without a temporary variable is a challenge. We can do it in several ways. Even I can do it in a single line, that we'll discuss in the future videos. So here we are targeting with only the average aspirants. So let's get into the a small concept called XR. If two are same, then it results in 0, right? It pulls it low, and if two are different, it results in high. So this concept we are using it. We'll write a small method, swap two numbers. If pointer A equals to pointer B, check if two addresses are same, return pointer A equal to pointer A cap pointer B equal to pointer A cap pointer B, pointer A equal to pointer A cap B, and this method when you call it, it simply swaps it. Suppose I have an X equal to 10 and Y equal to 10. I called swap two numbers with ampersand X and Y as my variables passing through the method, then it will result in X will contain 20 and Y will contain 10. Check for this, but we can do it in a much simpler way within a single line. That I'll explain it to you later. First you practice this stuff, okay, in the coming stuffs. So next question is clear all bits from MSB to the ith bit. Okay, here I have suppose data is storing using 8 bits in this explanation. So let's assume the ith position is 2. Mask equal to 1 left shift I plus 1 will give you 0 0 0 0 1 0 0, right? So now if we subtract R from the mask equal to mask minus 1, then I'll get 0 0 0 0 and 0 1 1. Using the mask, now we can clear MSB to it ith bits of data 15. Data equal to data and with mask, and this is how I can explain it with a small piece of figure. Okay, second position. So I'll write a small code like inside int mask equal to 0 and int I, that is ith position till you want to clear the bits, is data is 15 value of data, and shift ith position with this expression, and then mask is equal to mask minus 1 gives us some value. Now clear all the bits from MSB to the ith position. That can be done with ANDing the data with mask. Okay, this will result in clearing the all bits from the from MSB to the ith position. So let's think about we just saw about LSB. How would we do it with an MSB, and how we will do it the same with an LSB to the ith position. To clear it's same, the concept is same as far as this thing. To create a mask you have to create it I left shift, but here I plus 1, okay, will result in some value like this. If my value is 2 and 0 0 0 1 triple 0, then mask equal to -1, mask -1. From that all the bits from 0 to I become 1 and remaining bits become 0, right? After that perform the complement operation on the mask, that is here one addition is mask equal to complement of mask. You complement it so that I'll have something like this, okay. 1 1 1 1 1 1 0 0 0 0. Now just simply perform ANDing operation here, data equal to data and mask. Now the bits are clear now. So from LSB to the ith position, suppose this is the pictorial representation. So earlier we did with MSB to the ith position clearing. Here this it will result in clearing all bits from MSB to LSB to ith position. Let's see, the program is something like this. I hope this explanation is sufficient. Go through this program, because if you have doubts you go back to the previous explanation from for MSB to the ith bits. Here we will clear all bits from LSB to the ith position. Only difference here is we'll have mask equal to complement of mask, okay, and mask initially we'll do shift 1 ith position, okay. These two differences if you keep in mind, then you can clear you from LSB to the ith position, clear all from the LSB to the ith position. So next frequently asked question and most important question is multiply a number by 2 using bitwise operator. It's simple. Left shifting of a data by 1 is equivalent to multiplying the data into 2. Every bit is a power of 2. That is what binary concept is all about, right? So with each shift we are increasing the value of each bit by a factor of 2, right? So it's simple. I'll have a data left shifted by I times, that will give me the multiple of 2. The program is very simple. Data equal to data left shift 1 equivalents to data into 2, right? Then print the data, as simple as that. So dividing by 2 is something like a right shifting. Divide a number by 2 using bitwise operator. Earlier we saw multiplication by left shifting, right? Obviously right shifting will be equivalent to dividing the data as data by 2. In data every bit is a power of 2, right? With each right shift we are reducing the value of each bit by a factor of 2. So here it is also very simple. Writing a program is very simple. Data equal to data right shift by 1, which is equivalent to dividing by 2, right? Just print it, okay. Next question, let's move on to the next question. Multiply a given number with 3.5 using bitwise operator. We know multiplication is basically an addition, so we can multiply a given number data with 3.5 using the following operation. 2 star data, that is 2 into data plus 2 data divided by 2, right? We just saw how to multiply twice. That means left shifting a data will produce me data into 2, right? And just adding data and plus right shifting data. So program is very simple. Data equal to data left shift 1 plus data right plus data right shift 1. This is equivalent to 3.5. This is how we can go ahead with. And how to change The next question is how to change endians. We know about little endians and big endians. So I'll show you with an image. You can see the conversion, right? Something like I have 4 bytes, something like this. Okay, that means 4 will go to first position and 3 will go to the second position and 1 will go to fourth position and 2 will go to the third position. Okay, we'll write a small program for this. For this I take an example of 32-bit. I use int types uint32 change endians is the program. What I can do is u32 result or equal to u that value and with 0x last 2 ffs and left shift by 24 times. Then move that ff to the next byte and left shift by 8 times and move that ff to the next byte. Okay, and move right shift by 8 times and then move that ff to left shift left side and right shift by 24 times. Each and every time when we are doing it, we are adding with the u32 value and we get the u32 result. We give back that to the we return that value to the function. So here in an main function, how would I use it? Using a data, we'll go ahead and see. So I have a value data 0x 11 22 33 44. Okay, and I just call that function change endians and pass this u32 check data. What I'll get a result of it, printf %x of u32 result data, u32 check data equal to u32 result data. u32 result data is equal to check endians 32, again swap the data, printf, you'll get the result. This is how we can check through. Okay, let's see about swapping 2 nibbles of a byte. It's a very simple 4 bits form this thing nibble, right? So it's very easy question here. Left shift and a right shift operators are used to swap the nibble. It's very simple, isn't it? So we'll have a macro swap a nibble, something like data hash define swap nibbles data and 0x0f left shift by 4 or with data and with 0xf0 right shift by 4 times. This simply swaps the nibble, as simple as that. Left shift and right shift and perform an OR function, as simple as that. Here the masking is for the right nibble 0x0f and then for the left nibble f0. We are adding it so that we can get that particular nibble out, right? Adding me results in if 10 is 0, obviously I get the first nibble this side and left next nibble that side. That's how we will swap it. It's very simple. It's very simple. So let's move on to the next question. How do I get a bit from an integer value in C? To get the ith bit, perform ANDing operation between the ith bit and one left shift I. After that, shift the left ith position in right using the right operation. So I'll have a macro to get bit from the given position, something like get bits data position data and with 1 left shift position right shift POS, that is same position. So this will result in it. So how to call that is just simply value position, get bit value position, just directly print with So if you have a value, you just value composition will be passed to the through that macro, and then we can get to this thing. If position is equal to 4, you can get the other stuff. So let's move on to the next question. Write the macros to set, clear, toggle, uncheck the bit of a given number, which we discussed previously, but see the below macros. You can remember this macros which we already discussed on our embedded C FAQs, but anyways, we'll once again see hash set define set bit value comma position is r equals to 1u, that is 1 left shift position, or clear bit value position value and equals to complement of 1 left shift position. Toggle bit is XR equal to 1 left shift position, right? Hash define check bit is set or not. So value comma position value and with 1u left shift position. These are all cumulative stuffs which we discussed, and if you remember it, you can just simply write in a single line code and macro, which does not consume more this thing also. Let's see an example to set the bit using the above macro. This is how it goes. Okay, we just simply call that macro. So we'll get the value first, and then printf enter the position and get the position. Just call that macro set bit value comma position, then print the value and the position. As simple as that. So output would result something like this. I just had a screenshot of that. So I give 5, I get first bit set. Now value will be 0x7. Okay, let's move on to the next question. Write a macro to swap the byte in 32-bit integer variable. I have already written the program in endians conversion, right? But there is here I am creating a macro for the same. Okay, swap bytes. There we have written in separate lines. Here I have a macro left shift 0x, and with that value ff at the rightmost corner, and then move by a byte and left shift by 8 and move by a byte and right shift by 8, handing it and right shift by 8. I hope you understand the context here. So don't look at the expression properly. We have written separate expression with semicolon there. Here we'll go with the simple macro swap bytes. Okay, and if you have a data, just call that macro and things will get much easier. See the output. Before swapping it is 0x11223344. After swapping the result will be 0x44332211, something like this. Let's move on to the next question. Swap all odd and even bits. So you need to swap the even and odd bits, right? To accomplish the above task, you need to first find the even and odd bits, right? Let input number is data, assuming integer size is 4 bytes. That means given all even bits of data by doing bitwise and of data with 0x okay, something like this. Okay, then and with 0x 5555555555. Okay, that means complement of a is 55, right? We get the even bits and the odd bits, right? Okay, right shift all even bits data, and with that will stuff 0x right shift once, left shift all odd bits, that is data, and with 0x 555555 left shift 1, combine the value which gets from the left and right operation by this ORing those two expression, right? So the simple way and an example code is something like this. I have a data equal to 2 and I use this expression printf data. This is how we do. Okay, I hope you understood this. Let's move on to the next question. Count number of bits to a flipped to convert A to B. In this question, you need to count flipped bits that requires convert A to B. To accomplish this, you need to find the number of bits that are different in A and B, right? Suppose A equal to 8 and B equal to 7. So it will be 0 0 0 0 1 0 0 comprises A 8, okay, and all 1 1 comprises in the B. Here we have to flip highlighted 4 bits of A to make it B. The algorithm is very simple. Calculate XOR of A and B with help of XOR. We will discard the common bits and set the bits that are different in numbers A and B. Count the set bits of the above calculated XOR result. We'll see in a small code. So count flip bits. So I repeat, calculate XOR of A and B with the help of XOR. We will discard the common bits and set the bits that are different in numbers A and B. Count the set bits of the above calculated XOR bits. So this is the programmatic example code for it. XOR result equal to 0, count equal to 0, doing XOR A cap B, and while of XOR result, count plus XOR result and with 1 and right shift equal to 1, return count. This is how we get the count. So we can call this program in the main function something like this: return equal to count flip bits. So output will be something like flip bits equal to 4, obviously 8 7, right? So output should come flip bits equal to 4. So I hope you understood this. To understand it better, you need to take your compiler, write it, check the result, do all the possible combinations with various data and check these. Hope this is useful to you for bitwise operators. This can be much better optimized code in the form of macros, which we will be posting it after you understand this video. And please subscribe to our channel if you did not subscribe by clicking subscribe button. Thank you.